I hope every one of you love to ride on your cycles, right? I know you do. It's really fun to ride on one of those cycles. How I wish I could do that. Hmm, okay, never mind. But have you ever experienced difficulty in pedaling your cycles? Have you ever wondered why that happens? It's because the chain in your cycles is made up of a metal, and the metal in your cycle chain is undergoing a chemical reaction. These reactions which the metals undergo is called as their chemical properties. In this video, we are going to see about that in detail. Before we get into the lesson, I'm going to tell you an important matter. Don't drink water while studying because chemistry says that concentration decreases on adding water. Ha 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 ha. In this video, we will see the basic and amphoteric nature of metallic oxides. Mostly, many metallic oxides are basic in nature. Like for example, copper. We have already seen this equation in the previous chapter. CuO plus 2HCl gives CuCl2 plus H2O. Since copper oxide is a basic in nature, it reacts with but certain metallic oxides like aluminium oxide and zinc oxide react with both acids and bases to give salt and water. Since the metallic oxides show both acidic and basic character, they are called amphoteric oxides. Let's see why we call Al2O3 as an amphoteric oxide. Aluminium oxide, when reacts with hydrochloric acid, it forms aluminium chloride and water. Same way, aluminium oxide reacts with sodium hydroxide to form sodium aluminate and water. Most of the metallic oxides are insoluble in water, but some of them react with water to form alkalis. So, sodium oxide reacts with water to give sodium hydroxide, which is an alkali or base. Not all metals react with oxygen at the same rate. Certain metals like sodium and potassium react with oxygen more vigorously than other metals. For this reason, sodium and potassium are not kept in the open but immersed containers filled with kerosene. Do you know that metals like aluminium, zinc, and lead are covered with a thin oxide layer? The protective oxide layer prevents the metal from undergoing further oxidation. And also, iron does not burn on heating, but the fillings of iron burn vigorously when sprinkled on fire, since they have greater surface area. Copper also doesn't burn when heat is applied. Instead, it forms a black colored copper 2 oxide layer on its surface. And non-reactive metals like gold and silver never react with oxygen even at high temperatures. Reaction with water. Now we are going to see about a really cool topic. Have you ever heard of water causing anything to catch fire? Sounds alright? For this reaction, let's see about them. Number 1, metal could combine with water to form metal oxide and liberate hydrogen. The same way, it could also react with water to form metal hydroxide. The metals that we are going to see about in this topic individually are sodium, potassium, calcium, magnesium, aluminium, iron and zinc, right? Let's see about sodium and potassium first. Both these metals are highly reactive. So both of these metals react vigorously with water to form metal hydroxide and liberate hydrogen gas. This reaction is particularly highly exothermic. So it releases a huge amount of heat energy. This causes the hydrogen gas which is liberated to catch fire. We will see these reactions now. Now, both these metals react with cold water, which is to be noted. Up next is calcium. It also reacts with cold water to form calcium hydroxide. But this reaction is not so violent like that of sodiums and potassiums. So it does not catch fire. Instead, it floats on the surface of water. Then coming to magnesium, it does not react with cold water. Instead, it reacts with hot water to form magnesium hydroxide, which is also known as milk of magnesia, and starts floating due to hydrogen bubbles sticking to its surface. Now, the other metals like aluminium, zinc, and iron react with neither hot nor cold water. Instead, they react with steam, that is, water vapor, to form metal oxide and liberate hydrogen gas. And again, silver and gold do not react with water at all. Aluminium reacts with water to form aluminium oxide, and iron reacts with water to form iron oxide. Next chemical property is reaction with acids. Yes, I know that you have already learned about reaction of metals with acids in your previous chapter. But we are going to have a look at that once again. Let's see the basic reaction first. Metal plus dilute acid gives salt plus hydrogen. This time you guys are going to write the reactions of magnesium, aluminium, iron with dilute HCl and send it to me. Okay? Here's a note. Metals do not liberate hydrogen gas on reaction with nitric acid because it is a strong oxidizing agent. It oxidizes the hydrogen gas produced in the reaction into water, and nitric acid itself gets reduced to any of the nitrogen oxides like N2O, NO, and NO2. But magnesium reacts with very dilute nitric acid to liberate hydrogen gas. This is because of the high reactivity of magnesium. Remember the iron nail in copper sulfate experiment which we learnt in displacement reaction in our first chapter. But we didn't see why iron displaced copper from its solution, right? The reason behind that is nothing but reaction. Remember the iron nail in copper sulfate experiment which we learnt in displacement reaction in our first chapter. But we didn't see why iron displaced copper from its solution, right? The reason behind that is nothing but reactivity. Yes, iron is more reactive than copper. That is why it displaces it from its salt solution. Here's the basic reaction. Metal A plus salt solution of B gives salt solution of A plus metal B. Here, if A displaces B from its solution, then A is more reactive than B. Now, all metals have an order of reactivity. This is also called the reactivity series. The reactivity series is a list of metals arranged in the order of their decreasing reactivities. Now we are going to memorize this series in a really funny way. We are going to use a slogan to learn this reactivity series. Let's see what it is. It is, please stop calling me a careless zebra. Instead, try learning how copper saves gold. Please stands for potassium with symbol K. Stop stands for sodium with symbol Na. Calling stands for calcium with symbol Ca. Me stands for magnesium with symbol Mg. A stands for aluminium with the symbol Al. Careless stands for carbon with the symbol C. Zebra stands for zinc with the symbol Zn. Instat stands for iron with the symbol Fe. Tri stands for tin with the symbol Sn. Learning stands for lead with the symbol Pb. House stands for hydrogen with the symbol H, which is a non-metal, but still we have it in our series. We'll see about that later. Cu stands for copper with the symbol Cu. Save stands for silver with the symbol Ag. Gold stands for gold with the symbol Au. That's all for today's video, guys. I'll meet you all again in the next video. Until then, bye from your Estemis. Bye.